Hello friends, good morning. So what I have here in this session is very interesting. We are going to see about event handlers, and then we are going to see how we can develop a custom logging solution with the help of event handlers and catch the events as per our needs and then log them into our database. So this is a small template which I have developed for you in this demo session. So before we get into the details, let's try to see what I have done in the backend. So from a database perspective, we'll go through the small script that I have created. So this is nothing but two tables that I have here. I have created a very simple feeds table, which is kind of a repository of all the feeds that run, which has a feed ID identity column, a feed name, and a creation date. So it's just a kind of a simple demo that I have created. Next we have a feed logs table, which will be logging the feed's execution. So this has log ID, which is just an identifier, a clustered key. Then the feed ID. The feed ID is actually a foreign key reference to the feeds table. Next we have the job ID. Next we have the job ID, which is kind of a unique number for each execution, by which I mean if a package A has been executed now, it will assign a number for the complete execution of the package, and then again if it is executed tomorrow, a new number will be generated. We'll see the details how we will be achieving this. The next is the execution machine name, or the server name from which the package was executed. The details about package name, and then the task's name, the start time and the end time of the package, or the task, and then we have the error message if we have any errors occurring, where we'll be logging our errors. Next we have a small stored procedure. This stored procedure simply is executed to insert records into the feed logs. So it is nothing but it's taking the parameters and then inserting the records into the feeds log table. So currently if we look at, I have inserted two records. I have inserted two records on my feeds table. So I have just inserted two sample records with the feeds name, custom logging, and execute utility into my feeds table, and the feed IDs are auto generated as 1 and 2. The next we have the feed log table. This table is currently empty now. So this is the entire thing that we have done from the database perspective. Now let's move our attention towards the SSIS, what it is in SSIS for us. So here in SSIS we have a couple of things. Before let's get down to and study the event handlers first. So event handlers, if you look at, I have used three events that I would use that I would want to log. In my last session we had seen how logging occurs. The session on logging, we have logged on a text file, we have logged on XML file, SQL Server, Windows events, and then trace files for these three events, for pre-execute, post-execute, and error messages. So that was SSIS logging which was taking place. Here what we want to do is we want the package to run on these events, something which we want. It's kind of a try catch. So if any event occurs on error, what we would want to do, how would we want to handle the situation, is what happens into the event handlers tab. So if you look at, you will find these tabs, and in this tab you'll find two parts, that is the executable and then the event handlers. So let's drill down and first understand executables. So in executable, you can perform or catch any event handlers for any executables. So if you look at, currently we do not have any executables, and we have three event handlers which we have assigned, and this is the custom logging is the base level of the tree, so it is or the root level of the tree. So we want what I want to handle is on the complete package level. So I have selected custom logging, but if you see, if I create a SQL task here, example, let me just add a SQL task, and then if I simply go down to my event handlers, what I'll see is in my custom logging in the executables I'll have the task A. Now I can simply select the task A and not log upon the complete package. So it will the pre-execute event handler will be executed on the executable that I have selected. So it's very simple. The event handler of the pre-execute will be executed on the SQL task that I have selected and not at the custom complete package level. So that is the meaning of executable and event handlers. Now what we have here is pre-execute, post-execute and error. So let's try and understand what each of them do for us. So on error, what I have done here is I have a SQL task. I mean, the way I would want to handle this is I have a SQL task which is connecting to the OLEDB package logging connection, and what this does is simply inserts the records into calls the stored procedure and inserts the records based upon the error message. So now how is these variables mapped is on the parameter mapping. So if you look at, you'll have so the variable feed ID is a user defined variable. The others job run ID is a user defined variable. The others a machine name is actually a system defined variable. Package name also we have used. The error description or the error message is also system. The SSIS system variable itself generates and catches the error message. Then we have the source name, which is actually the task name. Now so this is what is being done in this SQL task. Similarly, in our post execute task also, what we have done is simply we are inserting, calling the stored procedures and then inserting the data. So here we are not going to insert any, there would not be any error messages. So it will be kind of null value will be assigned. Now let's take a look at the parameter mapping also. So if you take a look, the parameters are something like this. Again, the feed ID and the job run ID are user defined. The machine package and the task name are picked up from the package itself. Right then, so now before I discuss the pre-execute task, let me just go back to my control flow and show the variables that I have used here. So what I have here is a feed ID, which is manually the value, the feed that you are trying to map your value to from your database. The feeds table. Say you are developing a feed for feed ID 1, you just give a value of feed ID 1 to this variable. The job run ID, you do not need to assign anything, it's just a variable, and I'll tell you the reason why. The next we have a logging DB connection, which is just an expression for this connection string. It's kind of a connection string for this expression. So we can map this connection string to the logging DB connection. So if you take a look, it's mapping to my server, the server and this database where all the activities will take place. The other is on track on variable change of job run ID. We'll get to know both of these. Both of these, just count them as a zero assigned value. And then we have a var disable logging, which is a boolean value set to be true. Right. So just remember them, and next we move on to studying our pre-execute task. If you look at pre-execute task, what we have here is, what I am trying to do is I'm trying to fetch the maximum job run ID from the feeds log table. From this table I'm just trying to get the maximum job run ID. Currently this is empty, but this I'll just try to fetch the maximum job run ID and then put or insert the next value. And what I want is, throughout the run of the package, that job run ID should remain intact, because based upon the job run ID I would want to query my package execution. So what I have here is an empty SQL. It's nothing, just a flow identifier. Next I have here is a condition based precedence constraint, which says that if the variable is not equal to 1, if the change variable is not equal to 1, only then it will proceed to this flow. And the other one says if the value is equal to 1. So based upon that it will proceed to this task. So initially when the package runs, you know that this value is set to be 0. So this is the path where it will go. So if you see here in this task, what we are trying to fetch is the maximum job run ID from the feed logs table, and then incremented by 1. So the logic goes here, if you try to run this query, you will get a value 1 because there is no record. So this is the code for fetching the next higher value. Now next is we set the flag. So once we get the next value, we would not want to increase it for the entire package run. So this var variable needs to be static throughout the package run. So the job run, as we want the job run ID to be static throughout the package run and be logged into our feed log table. So in this script, immediately after getting the next higher value, what we do is we set the value of the on change variable to 1. That means we flag it. So the next time this flow of this part of getting the next higher value would not be done. So we will not transverse to this path. We would simply the next time when a pre-execute runs, it will simply go and log here in the pre-execute. So here if you see, it's similar. We are simply calling the stored procedure to log to call the stored procedure and then insert the data. So that's what's happening. And in the parameter mapping, we have the variable feed ID, job run ID, and the other details, similar to the post execute one. So that is in pre-execute. Now what I mean here is, when we run this package, the pre-execute will be run every time for each of the tasks that we have, and the post execute also. The error event will only occur in an event of error. So if there is no error, the error event handler would not be called at all. But the pre and the post execute will occur at the package level, at the task level. So every time it will be called. The last thing before we move on to see the rest of the changes, what I want here to discuss with you is, we had a variable called var disable logging. If you see here, sorry, just let me cancel this. If you see the variables, what you have here is var disable logging. Now what significance does this variable have? So what we have here in the expressions, if you go and take a look, you would find that we are assigning this variable to the disable property, which means this is a disable property is mapped to this variable. So it's kind of a switch that on the complete package level, if you do not want the logging to occur at all, so you can do so by assigning this disable expression property to this var disable logging variable. So we have done this for all the events. So in case you do not want this at all, you can simply do so and then disable the complete thing. So if we see the variables, we have set var disable to true, right? So that means the logging or the complete sequence will be disabled. Now let's try to run this package. Let me put some code. So I've just asked this task to wait for 5 seconds and then put some simple select one. So that's it. Now if I run this package, there shouldn't be any logging because we have disabled it, because the switch for this logging has been disabled. Right. So let's just go and check our feed logs table. It is empty. Now if I simply go ahead and change the variable, boolean variable, to false from true, our code will start executing and the package will start logging. Right. So this is what is happening. If you look at the logging feature, what we have here is the feed ID that it maps to, which is foreign key to the feeds. Next we have a job run ID of 1, the machine name from which the job was executed, the package name which got executed, the task name. The task name, we have the SQL task and the package. So we'll get at every level the pre and the post execute, and we have two entries for each of them. The reason is this entry is for pre-execute of the task, this entry is for the pre-execute of the SQL task A, this is for the post-execute, and this is for the post-execute of the complete package. So the pre and the post-executes will occur after for each of the tasks. The reason for having two records or duplicate entries is twofold. I do not, if I have 100 odd feeds and 50 of them are running at the same time, I do not want any locking or concurrencies. I would have used updates to go and update the same record sets, but it's better not to do so. The reason is, in this table you just to bring down the concurrency, just have two things on this table, two operations. So that would be select and insert. So none of the operations would create any locking issues. If you have just inserts, it will just be a heap insert, kind of a sorted way. The next would be your selects that you would want. So this will ensure that there is no locking, because this is a logging table. This will be logged at a very high speed by more packages running concurrently. So I hope I'm clear why I'm using two records and instead of one. The next thing I would want to show is, in the event of a failure condition, how do we get the data. So instead of select, let me make a spelling mistake and then run the package. Right, so this package has failed, and let's see what is being done for logging. So if you see, you get a new job run ID for the next execution. That was the logic behind the job run ID, a new ID to be generated each time the package runs, so that we can query it out very easily. Now what you see here is the pre-execute tasks and also the error message on the task on which the package failed. So you have the error message. So this is the error that has occurred for during the execution of this package. So the error message also gets logged into your table. Now with respect to querying, what I wanted to show you is, with this query, I mean, it's very simple. Because of the job run ID logic, we can get the execution time of the complete package. So that is the execution time of this package. Now if we look at task wise, what was the execution time, this query would give you the task wise execution time of the package. So if I want the execution time for job run id 1 and feed id 1, it would give me the execution time for this. So the point of job run id was to get a unique id for each runtime, and then which will enable us to query the execution times in a very efficient way, and help us get the details. So that was a very precise solution for custom logging. So this complete package could be used as a plugin for any of the package that you develop henceforth. So something like this you can have an infrastructure for logging for logging features that you would want, instead of having a text based or XML or SQL based logging. So it's good to have a custom logging plugin feature upon which you can simply download this template from your TFS, and then perform your changes or the package developments. This could be one of the standard guidelines for logging. I hope this is useful to you, friends. In the next session we'll take this forward and try to see how package configurations and can be integrated with this logging feature, and we can have a far better template to put to a development of SSIS packages. Thank you.